Okay, let's do example 4. The limit, or the function, is x cubed minus 2 over absolute value of x cubed plus 1. And we will want to find the limit as x approaches positive and negative infinity for this function. We're going to split it into two functions. When x is greater than or equal to 0, we want the limit as x approaches infinity of x cubed minus 2 over absolute value of x cubed plus 1. We're going to treat that as the limit as x approaches infinity of x cubed minus 2 over x cubed plus 1. We're going to divide everything by x cubed, which is going to lead me to the limit as x approaches infinity of 1 minus 2 over x cubed over 1 plus 1 over x cubed. The limit of these two fractions, of course, is going to be 0. This answer is going to be 1. When x is less than 0, we're going to find the limit as x approaches negative infinity of x cubed minus 2 over the absolute value of x cubed plus 1. We're going to treat that as the limit as x approaches negative infinity of x cubed minus 2 over negative x cubed plus 1. When we divide by x cubed, we're going to have 1 minus 2 over x cubed over negative 1 plus 1 over x cubed. This time my answer is negative 1. The horizontal asymptotes here, y equals 1 and y equals negative 1. Now I want to show you this graph from the book. Here's our graph. Here's line y equals 1, line y equals negative 1. The graph crosses the horizontal asymptote for y equals negative 1, but the place that it crosses is on the positive side. Okay? This is the horizontal asymptote when x is less than 0, and this is the horizontal asymptote, and 1 is the horizontal asymptote when x is greater than 0. So note that stipulation there. Okay, example 5. We want to find the limit as x approaches infinity of the sine of 1 over x. And we're going to introduce a new variable here. The variable t, which is equal to 1 over x. Now, as x approaches infinity, t approaches 0 because t is equal to 1 over x. Okay? So as x approaches positive infinity, t approaches 0 from the right. So the limit as x approaches infinity of sine of 1 over x is equal to the limit as t approaches 0 from the right of the sine of t. Now, sine of 0. What's the sine of 0? Sine of 0 is 0. Approaching it from the right, we're going to have an answer here of 0. Now we're going to calculate the limit as x approaches infinity of, this is our next one, x times the sine of 1 over x. Okay, if t equals 1 over x, like we did at the beginning, multiply both sides by x. X times t is 1. X equals 1 over t. So I'm going to keep that in mind. T equals 1 over x. X equals 1 over t. Okay, so this is the limit as x approaches infinity of x times the sine of 1 over x. Now I'm going to switch it over to t. Limit as t approaches 0 from the right of 1 over t times the sine of t. Now, what is 1 over t? One over 0 from the right. It's going to be a positive value. It's going to be very, very, very large. And the sine of t is going to be the sine of something very close to 0. So this has a limit of 1. If I approach from the left, or if I evaluate the limit as x approaches negative infinity of x times the sine of 1 over x, we treat that as the limit as t approaches 0 from the left of 1 over t times the sine of t, and that also has a limit of 1. So we know that y equals 1 is a horizontal asymptote for this function. Okay, homework problems that I want you all to try from this lesson. We're nowhere near the whole lesson, but I do want you to try. 1, 5, 4, 7, 8, 13, 14, 16, 20, 23, 25, 26, 27, 30, 31, 33, 34, 36, 37, 39, 42, 43, 44, 45. I know you won't get all of these completed by the end of the day, but I just wanted to give you something to look at.